Let's look at the nomenclature. In IUPAC nomenclature, benzene is designated as a parent name, which we'll name it as benzene. Then other compounds that attach to the benzene molecule will be considered as its substituents. In the case of monosubstitution, which means one of the hydrogen atom is replaced with other compound, then the prefix of the substituent is added to the name benzene. More easy way to understand, just look at the examples of compound here. We have benzene structure and bromine is attached to it. So the parent name is benzene and bromine is attached to benzene, so it is the substituents. So it named as bromobenzene. Same thing for the second example. Nitro group NO2 is the substituents. So it is named as nitrobenzene. Certain substituents attached to benzene will have a new name for it. That's why mentioned here. In other cases, the substituents along with the benzene ring forms a new parent system. So all these you have to memorize. Okay, all this you have to memorize. Okay, the first one has methyl group CH3 attached to the benzene ring. We call it as methyl benzene. At the same time, it also called as toluene. That's the new name that I say you need to remember. Next substituent is OH, and attached to the benzene ring is named as phenol. Then we have NH2 attached here, so it's called as aniline. And then we have aldehyde group CHO, okay, attached to the benzene ring, so it's called as benzaldehyde. Then we have the OCH3 methoxy group, okay, so it's called as anisole. Then with COOH, and it's called as benzoic acid. And then we have the amide group CONH2 attached to the benzene ring, and it's called as benzamide. Then with SO3H, and it's called as benzene sulfonic acid. And lastly, we have the CN, we call it as cyano or nitrile group, called as benzonitrile. Next, how about benzene with two substituents? In disubstituted benzene means with two substituents, three isomeric structures are possible which have substitution at 1,2, 1,3, and 1,4 positions. We name the substituent with its position number. The substituent can be named as auto if they are at the position of 1 and 2. It will be named as meta if their position at 1 and 3, and named as para if their position is at 1 and 4. Although meta para can use the short form as O-, M-, and P- respectively. Look at the first examples here. Okay. We have two bromine here at the position of 1 and 2. So it's named as 1,2-dibromobenzene, or written as O- dibromobenzene, which the O's is referring to auto. Next, the two bromine is at the position of 1 and 3. So it's named as 1,3-dibromobenzene or M-dibromobenzene, where the M is referring to metal. Okay. Then we have the third one where the bromine is attached at the position of 1 and 4. So it's named as 1,4-dibromobenzene or P-dibromobenzene, which the P is referring to para. Okay, next, look at the second row of the examples here. Okay, the first one have two substituents, COOH and CH2, CH3. If you remember just now, we learned about the new parent name, right? So here, COOH attached with the benzene ring. So the new parent name is called as benzoate acid. And since the COOH together with the benzene ring give the new parent name, so the carbon with the COOH is at position 1. So that means here is position 1. Here is the carbon at position 1. That's why the substituents of CH2, CH3, okay, here is the carbon with position 2. Hence, the naming is 2-ethyl benzoate acid or O-ethyl benzoate acid. The O is referring to auto. Okay, and then we have next is almost the same. Okay, just that ethyl group now is at the position 3, so it called as 3-ethyl benzoate acid or M-ethyl benzoate acid. And the last one, okay, the CH2, CH3, the ethyl group is at the carbon number 4. Okay, 1, 2, 3, 4. So it named as 4-ethyl benzoate acid or P-ethyl benzoate acid. Next, if two different alkyl groups are present, they are numbered in alphabetical order as in the following case. Okay, here we have a methyl and ethyl group. So we number it according to alphabetical order. So will be ethyl first, okay, then methyl. So it called as 1-ethyl 2-methyl benzene, and it's not 1-methyl 2-ethyl benzene because follow alphabetical order. E first, then letter M. And if more than two different substituents are present, they are numbered in alphabetical order. Example here, we have a chlorine, okay, we have chlorine, bromine, and iodine as the substituents. So either is turn this way around or turn this way around. So we need to confirm Cl order I first because bromine is definitely in the middle. So as mentioned, need to number it according to alphabetical order. So the chlorine is at position 1 because with the letter C. Okay, then followed by bromine, the position 2, and then iodine is at position 3. When write for the name, don't just write follow the number. Means don't write it as 1 chloro, 2 bromo, 3 iodo benzene, which is wrong because we need to write according to alphabetical order as well. So B first, okay, which is the bromine at position 2, okay, then followed by C, chloro, lastly I, letter I, iodo. So the answer will be 2 bromo, 1 chloro, 3 iodo benzene. Next, if more than two substituents are present, their positions are shown by number in such a way that the substituents are at the lowest possible positions. The first example is easy. We have 3 bromine as substituents. So it will be tri-bromo, and they are next to each other. Either you put the position number from the left to the right or from the right to the left. Also will give you 1, 2, 3 tri-bromo benzene. And other examples, we have 3 chlorine as the substituents. So we will have trichlorobenzene. We need to decide the numbering. You will get 6 possible answers for the numbering of chlorine. You can list out all the possible number first. Each of this chlorine here, okay, each of the chlorine here can put as position 1. For example, here can be 1, okay, then turn this way around. So here will be, this chlorine will be at position 3 and then position 4, okay, or I put this chlorine as position 1 first and then I turn this way around, okay, so this one will be number 2, okay, here will be 5. Or I put this one as position 1, okay, again, but I can turn this way around. So here will be position 3, okay, and then here will be position 6. Okay, so the possible numbering can be either 1, 2, 4, 1, 2, 5, 1, 3, 4, 1, 3, 6, 1, 4, 5, and 1, 4, 6. So based on all the possible answer, which one has the lowest possible position? It is 1, 2, 4. Okay, 1, 2, 4. Because all the substituents chlorine here are at the lowest possible position. So by comparing the rest of the 5 possible, this one has the lowest possible position. So the correct answer will be 1, 2, 4 trichlorobenzene. Next, whenever a substituent can give a new parent name with the benzene ring, for example, toluene, aniline, phenol, then the carbon atom that carries the substituents is now recognized as the position 1. Then the position number of rest of the substituents will be assigned accordingly. This actually already mentioned when we look for the examples for auto, meta, and para. Never mind, we just look at more examples here to understand more. The first example shown here has 3 substituents. Okay, we have here CH3, NH2, and also Br. If you remember, if CH3, a methyl group, is attached to the benzene ring, it has a new parent name called as toluene. And NH2, an amino group attached to benzene ring, it also has a new name called aniline. Another substituents, bromine, attached to the benzene ring, will not give any new parent name. So the carbon with bromine definitely will not be at position 1. So for this example, we have 2 answers. If you choose toluene, okay, as the parent name, then the CH3 will be at position carbon number 1. Then the bromine or the NH2 will be position 3. Okay. How you decide which one is at position 3? Okay. We need to number them according to alphabetical order. NH2 is amino with the letter A, and bromine is bromo is with the letter B. So is amino first, then only bromo. So lastly, the answer will be 3 amino 5 bromo toluene. Another correct answer is if we take aniline, okay, as the parent name. So the NH2, the carbon here will be as the carbon position number 1. And now either the bromine Br or the CH3 will be the position 3. Again, how to decide which one is at position 3? It's according to alphabetical order. So CH3 is methyl, so it's with letter M. Okay, and bromine is bromo with letter B. So it's bromo first, then only methyl. And at the end, you will get the answer as 3-bromo, 5-methyl, aniline. Okay. Next example has 2 chlorine and 1 OH. Okay, the Cl attached to benzene ring, okay, Cl attached to benzene ring will not give any new parenym, but OH attached to benzene ring will give you a new parenym as phenol. So the OH here is at the position 1, and the 2 chlorine are the substituents, and you will get either 3,4 or 4,5 for the position of these 2 chlorine. The correct one is 3,4 dichlorophenol. Okay, because they must be at the lowest possible position. Next, we have 1 CH3 and 2 Cl. So by now, I think you already know which one will give you the new parenym, which is CH3 as toluene. So CH3 is at the position 1, and the numbering of the Cl, the chlorine, must be at the lowest possible position. So you will get 2,4-dichlorotoluene as the answer, and it's not 4,6-dichlorotoluene. The last examples, we have 3 NO2 nitro group and 1 CH3 group. So again, CH3 is at position 1 and the parenym is toluene. So the answer is 2,4,6-trinitrotoluene. Don't forget to write di or tri if the compound has 2 or 3 same types of substituents. Okay, now let's move to another condition of naming. This one's special a bit. Normally, we put the benzene as the parenym, right? There are some cases where benzene is not put as the parenym, but as a substituent and named as phenol. When a benzene ring is attached to a chain containing 6 or more carbon atoms, or attached to a carbon containing other functional groups, for example, unsaturated chain like alkenes, even with fewer carbon atoms, the benzene ring is considered as a substituent, named as phenol, with the formula of C6H5. So we look at the examples, it will be more easier to understand. For the first one, we have benzene ring and an aliphatic chain with double bond. Okay, aliphatic chain with double bond, which is a propane attached to a benzene ring. So you see the chain, although it consists of 3 carbons only, but is an unsaturated chain. So this chain will be the parent part, while the benzene will be the substituents. That's the meaning of what is stated here. Okay, a carbon containing other functional group, for example, unsaturated chain, even with fewer carbon atoms. So the propane is the parent name, the phenol is the substituents, and we need to put the position of the substituents for the phenol. What you need to do is you need to confirm and settle the name for the parent part first. Okay, now the parent part is the alkene. Okay, it's the unsaturated chain. As usual, when you name for alkene, you will put the priority at the double bond for numbering. That's why here is 1, this is 2, and this is 3. So the position for phenol is 3. The phenol is attached at the carbon number 3. And the answer is 3-phenol, 1-propene. Next example is a chain also, and it consists of 7 carbons, which is more than 6 carbons. Okay, which is a chain, okay, containing 7 carbon. So this chain will be the parent part, and benzene ring is the substituents, called as phenol. So since the chain is an alkane, you may put the position 1 here or here. Okay, if you put the precision at the end here, okay, at the end of the chain here, then the phenyl group attached to the chain, okay, will get the largest number, which is 7. That means if you put here as 1, so here will be position number 7. So this phenyl is attached to the carbon number 7. So it has the largest number. So of course, according to IUPAC nomenclature, we need to get the lowest possible position. So this carbon will be at position 1. And the naming is 1-phenyl heptane. Last but not least, the group with the structure of C6H5CH2 is called benzyl. The structure of C6H5 is called phenyl, but together with CH2 become C6H5CH2 is called as benzyl. Here are the examples. You see this chlorine, okay, this Cl is not directly attached to benzene ring. The structure here is benzene with CH2, then only Cl. So this C6H5CH2, okay, is called as benzyl. And the answer is benzyl chloride. Next one is almost the same. The OH is not directly attached to the benzene ring. Here has the CH2. Okay, so it called as benzyl alcohol. Now let's do the exercise. Give the name for the following compounds. This compound, for the first one, it has a benzene ring and an aliphatic chain attached to it. Like we learned before, it has a chain containing other functional group, for example, unsaturated chain, even with fewer carbon atoms. So the benzene ring is considered as substituents. So the parent name is propyne. Okay, the parent name is propyne, and phenyl is the substituents. The numbering for the phenyl is 1 because the position 1 should put at the carbon which contain triple bond. Okay, so this is which is here. Okay, so the answer is 1-phenyl propyne. Next, the structure also has aliphatic chain and a benzene ring. The aliphatic chain is an alkane and the longest chain containing 6 carbons. So this is the parent part. Okay, this chain is the parent part. Now for the numbering of the chain, is either we start here, okay, here as 1, 2, 3, 4, 5, 6, or we start at here as 1, 2, 3, 4, 5, 6 for the longest chain. Okay, so if we start the carbon as number 1 is here, okay, then this position of phenyl is at position 3. So if we start here as 1, then this carbon will be as carbon number 4, position 4. So have to choose the lowest possible position, which the phenyl is attached to carbon number 3. That's why the answer is 3-methyl 3-phenyl hexane. For question B, draw the structural formula for the following compounds. I think drawing is much more easier. Just need to know the term is indicate what. So for the first one, look at the parent name. It's benzaldehyde. So it's a structure of benzene with aldehyde group, CHO, attached to it. Hydroxy is OH and methoxy is OCH3. So this is the answer. Next, the parent name is anisole. Anisole is benzene with methoxy group OCH3 attached to it. Then we have ethyl CH2, CH3 is at position 4, and fluoro F attached at position 2. So this is the answer. Next exercise, give the name for the following compounds. The first one is benzene ring with Cl and COOH. Is there any new pairing name? Yes, with COOH is called as benzoate acid. So the position of COOH is at position carbon number 1. And the lowest possible position for chlorine is 3, not 5. So answer is 3-chlorobenzoate acid or M-chlorobenzoate acid, where the M is referring to meta. Okay, it's meta since the substituents is at position 1 and 3. Second structure. What is the pairing name? Benzene with chlorine do not have any new pairing name. With NO2 also don't have, but with NH2 is called as aniline. So NH2 is at position 1. Then the position of NO2 is 2, and then the Cl is at position 3. So the answer is 3-chloro-2-nitro-aniline. Not 2-nitro-3-chloroaniline, because must follow alphabetical order when we write the name. Need to write the letter with C first, then only N. The last structure has Cl and 2NO2 as substituents. So we know here do not have any new pairing name. So the pairing name is benzene. The lowest combination possible is nitro at position 1 and 4, and chlorine at position 2. So the answer is 2-chloro-1,4-dinitrobenzene.